Hey guys, Mr. Larson here. Listen, I'm going to run through some notes with you on rational equations. The two warm-ups here, the first one might be a little tricky because it's factoring with multiple variables, so I went ahead and did the first step of factoring. From there, it's just simplifying. And then number two is relatively basic rational equation. So why don't you pause, try to do number one and number two, and I'll work through the solutions before we get into the notes. Okay? Okay, so for this first one, since we're fully factored, we can just look to cancel, right? So I see this is really just all one fraction since it's multiplication, right? These are just being multiplied. So I can cancel from the top of the first fraction to the bottom of the second one, right? So x plus 2y, x cancels with one of these x's, so I no longer have x squared. And I think that's it, right? So on the top I have x minus y, bottom I have x, and then x plus y times itself, right? So x plus y squared. Awesome. Okay, so for the second one, fractions equaling fractions, right? We can cross multiply. Make sure when you do cross multiply, you're doing it correctly. Some people think that means literally just go straight across. It's actually the diagonal. So set one diagonal when multiplied equal to the other diagonal when multiplied. So 5x plus 6 times 1, it's just 5x plus 6. That's going to be equal to 2 times 10x plus 3, so 20x plus 6. All right, let's get x's to the left. Let's get constants to the right. And what do we have? Negative 15x is equal to 0. Divide by negative 15, divide by negative 15, and we get x is equal to 0. You could plug that in. That'll be 0, that'll be 0. You can see we have 3 over 6. That is equal to 1/2. Okay. All right, so we're going to look at three. That was one approach to solving a rational equation, cross multiplying when you have a fraction on one side and a fraction on the other side. We're going to look at that plus two other techniques. All of them work the same, so it's kind of similar to solving a system of equations by either elimination, substitution, or graphing. They all work for all systems, but strategically we may want to pick one method over the other. Same goes for these, okay? So I'll show you the same problem solved three different ways, and you can see that we're going to get the same answer every time. All right, the one I just did, which was cross multiplying, that's actually step B down here, or approach B. Approach A is if you just have one fraction equals 0, right? Anytime you're setting a fraction equal to 0, you're really claiming that the numerator is equal to 0. So it doesn't matter at all what the denominator is at that point. You can simply set the numerator equal to 0 and solve, okay? For method C, if you have a fraction equals a fraction, and this is different than B in that if they have a common denominator. So your fraction on the left side has the same denominator as the fraction on the right side. We can ignore both of those denominators and just focus on the numerators and set them equal to each other. Okay, so think about it like this. If I have 1 over 2 equals x over 2, what's the only number that x can be if these are truly equal? Well, doesn't it have to be the same as that value? So it would have to equal 1, right? If you have two fractions that are equal and the denominators are equal, the numerators have to be equal. Otherwise, they wouldn't be equal fractions, okay? So we'll run through number 3 down here, all three of those ways. And we're also going to touch on extraneous solutions. Extraneous solutions are solutions that you find throughout the process of solving the problem, but when you plug them in, they don't end up working. They'll generate a undefined fraction, so you can't even really solve anymore. Okay, so it's kind of like a false answer. It says it's an answer, but when we plug it in, it doesn't really work. Okay, so for number 1, let's talk about method A first, which was if a fraction is equal to 0. So currently we don't have that scenario, but what I want to do is bring everything over to the left side. So let's subtract this fraction, let's subtract 40 over x squared to the left side. So that gives me 1 minus 3 over x minus 40 over x squared is equal to 0. So I did get 0 on the one side. Now I need to combine all these to get one fraction on the left side. Okay, so I want to have a common denominator of, looks like x squared. So I think we can agree 1 is really x squared over x squared. And 3 over x, if I multiply by x on the top and bottom, I get 3x over x squared. And that's going to give me enough to get one fraction on the left side. Right, so I would have x squared minus 3x minus 40 all over x squared is equal to 0. And really what we're doing is multiplying both sides by x squared. When I do that, my denominator here is gone, and 0 times x squared on the right side is still equal to 0. So essentially we're saying, okay, as long as the numerator is equal to 0, we should be good. So x squared minus 3x minus 40 equals 0. I'm going to hop on my factor tractor. Can't believe you just said that. Okay, so x minus 8, x plus 5, x equals 8, and negative 5. Those would be my solutions. So maybe I should have done this part first, but that's okay. We want to make sure that neither of those are extraneous solutions. So think about your restricted values. Okay, what are your domain restrictions? Well, for number 3 here, if I look at my denominators and set them each equal to 0, these will both have x equals 0 as the value that creates 0 on those denominators. So we need to claim that x cannot equal 0, right? We're checking our domain restrictions. So luckily for us, neither of these are 0, so neither of them are extraneous. They'll both work out. Okay, let's do that same problem. Method B, a fraction equals a fraction. So from my original equation, if I make this 1 and x over x, then I can say fraction equals a fraction. So x minus 3 over x equals 40 over x squared. Fraction equals a fraction. Let's cross multiply. So 40x equals x cubed minus 3x squared. All right, so I cross multiplied. Now I solve, right? Let's get everything to one side. So if I subtract 40x over, that gives me 0 on one side, and I'm going to flip these around. So I get x cubed minus 3x squared minus 40x equals 0. If I take out an x, we can see that inside the parentheses is the same as what I had on the left side, so it'll factor the same, right? So x times x minus 8 times x plus 5 is equal to 0. And this is going to give me solutions of x equals 0, 8, and negative 5. So hold on, I got two answers before. I got two solutions of 8 and negative 5. Now I got those again, but I got an additional solution of 0. Well, because we did this work over here, I know that 0 is extraneous. It's not going to work. If I plug that back in, I'm going to get 3 over 0. It's undefined. I'll also get 40 over 0. You only need one undefined for it to be extraneous. So all we need to do is cross that 0 out. You don't even have to list it as a solution. If you do, just make sure you point to it and say this is extraneous. Okay, so 0 would be an extraneous solution. Okay, let's take our method C. So fraction equals a fraction, but they both have common denominators. So I think I'm going to pick up from this step right here, because I'm going to get to that point anyways, right? And all I want to do is write that fraction over again, but I want to have x squared as my denominator on both of them. So I'm going to multiply this fraction on the left by x on the top and bottom. So that'll give me x times x minus 3 over x squared equals 40 over x squared. Okay, so basically what I did, I didn't show all the steps. I took this and I got x squared as a denominator on all these terms, and then combine the left side. Okay. So once we're to this point, so I have x squared as my denominator on both. So I can ignore those and just focus on the numerators, because again, if these two fractions are truly equivalent and their denominators are the same, that means their numerators have to be the same. So we can just look at the numerators. I'm going to distribute the x times x minus 3. That's got to equal 40, and you guys can see pretty quickly here that we're going to end up getting the same solutions. Okay, so you can decide which one you think is best. I don't know that there's really a best way on that one. They all kind of get you there with a fair amount of work. Okay. So what I'd like you to do is try number 4. I'm going to work through that one. I will not show 5 on the screencast, but you can check the work on the key. Pick your best method and go from there. So if you want to pause and try it, you can come back and watch me work through it. All right, so for number 4, first thing I'm going to do, I'm going to notice that my denominator on the right side is not factored. So let's factor that. And that's going to kind of give me a look to see like what's going to be my best method. And also it's going to tell me my restricted values. So I know right now that x cannot equal -5 and +2. Okay, so let me list those as restrictions. If those show up as solutions, I can cross them out and say they're extraneous. So let's see. I think I'm going to try to get a fraction equals a fraction. So let me work on the left side here. I need to multiply by x minus 2 over x minus 2. This one, x plus 5 over x plus 5. So that'll give me 3x minus 6 plus x plus 5 all over, I'll leave this factored on the bottom. Okay, so I wasn't planning on this. I wasn't necessarily trying to get the same denominator on each side. I was just trying to combine the left side. But what I managed to come up with, and this will make things easier, is that I do have common denominators on both sides. So this would be my third approach, right? If you have a fraction equals a fraction with the same denominator, ignore those denominators and just set the numerators equal and solve. So that's kind of nice. So let's just focus on these and claim that they're equal. So let's subtract 7 over. I get 3, oh, I'm sorry, this should be 3x squared. 3x squared. What did I do there? Yeah, I forgot the x, so it should be minus 6x on that one, right? 3x squared minus 6x. Yeah, I only distributed 3. I should have distributed 3x. Okay, so minus 5x. That was my first mistake of the year. Minus 2 equals 0. This will factor as, let's see, x minus 2 plus 1, I believe. Yeah, so I would get x equals 2. And then let's see, subtract 1, divide by 3. I get negative 1/3. Okay, so let's just double check. Oop, I do have one that's restricted. So 2 won't work, right? When I plug in 2 right here, 2 minus 2 is 0. When I plug in 2 here, I'm going to get 0, so I get 0 a couple times. So the only solution here is x equals negative 1/3. Okay, so hopefully that helps. Again, check the key for 5. You might notice that you already have everything on one side, so I would try to get one fraction equals 0, would maybe be my approach, and then just claim the numerator equals 0, and solve it that way. So do your best, and thanks for tuning in.